Hi guys, Shouvik and welcome back to our YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes guys, so I actually busy with some other works in last, like mostly last 3 to 4 days, and also like some health issue also, so not able to upload the videos on the regular basis. But yeah, like we have solved like mostly like all the problems of the last week. So I will do a like rapid updations, rapid explanations of the videos that we have solved, and we'll try to put all the videos as soon as possible. Yeah, so I will first try to put the today's video. So let's focus on the today's videos first, and then post that I will accordingly upload the other day's videos also. So all the videos, all the solutions we have at the problems we have solved, just need to like put the explanations for you guys to your plate, and after that we are good on the place. So yeah, so first focus on the today's problem. Yeah, so on this today's problems, we have like maximum Manhattan distance after k changes, right? So this problem is tagged as a medium, and I feel so like it's an indeed medium hard kind of problems. Like I actually like these problems on different bar, because this actually a common kind of, I don't have to say template, a commons like popular algorithms you have to fits to solve this particular group of problems. If you know, then only you are able to solve. Otherwise, like you have to do a cultivations a little bit more on this math variants of these particular problems. Yeah, so on this problem statement, given a string is consisting of characters north, south, east, and west, where SI indicates movement in an infinite grid. Now, in stands for move north by 1 unit. Similarly, south, east, west. Initially, you are at origin 0, 0, and you can change at most k characters to any of the four directions. Find the maximum. Very simple, right? Okay, still now there is no super English or super complex things they have put to our plates. So we are at standing at an infinite grids of 0, 0 index, right? And from there we can move. We are moving to an infinite grid starting from origin, that is of 0, 0, and we can move to accordingly north, south, east, west, and when there is a k factors is given to us, so we are allowed to change at most k characters to any of the four directions. So that we are allowed to do so. Now after doing so, what we have to return? We have to return the maximum Manhattan distance from the origin that can be achieved at any point of time, not the end of the game. We have to like store at any time what is the maximum Manhattan distance we can get to at any point of times. What is the Manhattan distance, and maximum Manhattan distance is possible, and we have to return the maximum of those while performing the movements in order. So the movements we have to perform in order, like from left to right. So on this example test case, you can see, right, north, west, south, east, and k is given as 1. So what we can do, we are just changing S2 from north to from south to north. So this value we are changing from south to north. And what we can achieve, what is the max? So our resultant string is becomes northwest, northeast, right? Northwest, northeast. So S0 is north. So 0, 1. What is the, so the point is 0, 1, right? We are at position 0, 1. So what is the Manhattan distance? So the Manhattan distance formula is xi, yi, and xj, yj is xi minus xj plus yi minus yj. We have to take the sum of those. Absolute of xi minus xj plus yi minus yj. Agree guys? Agree? So now here you can see, for our case, one is like, if I consider xj, yj at origin, then it is always to be 0, 0. It is always to be 0, 0. So our case, we have to basically maximize xi and yi. So xi plus yi should be maximized. Now if I going to process this in order, so 0, 1. What is the Manhattan distance? 1. Minus 1, 1. Then we move to west. Then it becomes minus 1, 1. So Manhattan distance becomes 1 plus 1, because it's absolute. Right? So 2. Then we moved minus 1, 2. Manhattan distance becomes 1 plus 2. That is of 3. Then we move east. Then it becomes 0, 2. So the distance becomes 0 plus 2 is 2. But we have to take the maximum. So we already got 3. So we don't have to consider 2 at this particular points. It should be 3 only. So similarly, you can do for this, and you will going to get the answer as 6 on this particular case. And here you can see the constant is in the range of 10 raised to the power 5, and our k factor is in between the range of s dot length, and s consists of north, south, east, and west, these characters only. as our ace is 10 raised to the power 5, so we definitely have to think of kind of big of n or big of n log n kind of solutions for sure. So now try to build our intuitions. Now go to our favorite OneNote and try to build our intuitions. So what actually, by seeing the problems, what actually coming to my brain? So it should be north, south, north, then east, then some west, then some west, something like this. So we have an answer. So we have to return an answer. To at any particular time, like when I am here and I am bound to process them in order. That is from left to right. I have to process. Now let's suppose at any index, let's suppose I Manhattan distance I got at result 1, right? Result 1. On this index, let's suppose I got the result as result 2. So like this way, for every index, what is the I will take the Manhattan distance, the maximum Manhattan distance I can form, and I have to take the max of all those, like max of like result 1, result 2, result dot n. Like this way, I have to take maximum of all those, correct? So now, okay, Shouvik, it's clear. But tell me, how you can at any arbitrary points, how you can get your maximum Manhattan distance till now you can build. Processing them in order, that is mentioned in the question, right? Processing them in order. How you can tell me at this particular index, that is the maximum Manhattan distance we can achieve. That is the maximum Manhattan distance from left to right. If you are processing the orders in series, then that is the maximum Manhattan distance you can achieve. How you can tell me this? How you can tell me this information? So now let's focus on our Manhattan distance formula. So what we actually have to do, if I am at origin, so if I am going to consider I am from origin, so I have to maximize my Manhattan distance. So I know my Manhattan distance is actually taking x1 minus, if I am going to consider it 0, 0. So let's suppose I am at 3, 4. So let's suppose I am at this index, right? 3, 4. So the Manhattan distance is nothing but this plus this, delta between absolute of this and absolute of this, right? They are sum. The sum of this and this, both sums we have to return, right? Both sums we have to return. So from very naked eyes, can you guys point like my x calculations, like my x-axis calculations, if I am going to consider this as an x and this as an y-axis, my entire x-axis calculations. So on x, how far we move from here? I have moved to plus 3, and on y, how far we have moved? Plus 4. So can I say my x calculations is independent from y, from my y calculations. So similarly for y, it's independent from x. Agree? So my both axis calculations are independent. So I have to independently maximize those. Because it's a Manhattan distance. So we are taking x1 minus x2, and for our case, x2 is always going to be 0, as we already discussed. So so on x, how far from this y-axis, how far either left or either right I can go, right? That's exactly I have to find. Or if I'm going to consider y-axis in north and south terms, how far from this x-axis, either in north or either in south, I can go for a particular point. Which particular points? So this is a particular index I am considering this index. So for this index, let's suppose as we discussed, right, north and south calculations are independent, right? North and south, not like x-axis and y-axis calculations are independent. So north and south are only dependent. So now I have a grid. So if I am at a particular point, so I have some count of north. Let's suppose I have encountered some count of south. I have encountered. So now with this, and I have a k factor, So this is the information I have it. When I have iterating from left to right, how many north I have encountered till now, how many south I have encountered till now. This information should I have it in my hand? In a variable format when I am iterating from left to right. So now at any particular index that we are repeatedly highlighted, so at that particular points, I have to check. Firstly checking for north and south, right? So from this particular index, how far either at top or either at bottom I can go. Either at top or either at bottom I can go, right? So what I need, so because my delta is nothing but north basically going to neutralized. So I have to take north minus south. So is the absolute, this absolute I have to take. So I basically what I have to do basically here, I have to decrease if there are, let's suppose 3 north, if let's suppose there are 3 north I have encountered till that point and 2 south I have encountered till this point, with the k factor I know, with the k factors I can change any numbers to any directions to any other directions, so let's suppose I have k equals to 1, right? K equals to 1. So currently what is the my resultant Manhattan distance from the origin is nothing but 3 minus 2, because I am going plus 3 up then minus 2 down. So if I am going to consider it kind of index, so let's suppose that is of 3 and then I have moved to minus 2. So my resultant is becomes this, so that is of plus 1. So how we can so what actually neutralized my result? Can I say it's nothing but this south. So I know as my north count is maximized, maximum, like compared to south, I have three times I can go to north. So very greedily I can say I have to focus to north only, so that if I can move some south to some north bucket by using the k factor. So what I can do, so currently I am getting the result as plus 1. So now I am going to move 1 south to north. So south becomes 1 and north becomes 4. So my resultant becomes 4 minus 1 is 3. 4 minus 1 is 3 I am getting. Initially I am getting 1. But if I am doing reverse, rather than moving 3, I am moving this to 2. I am making it 1 south and this one is 2, right? This one is 2, right? So I am moving it to 3. I am making 1 north to south, 1 north to south. Then also my resultant becomes 2 minus 3. What was actually initially it was 1 and now also it was 1. So now actually it is minus 1. So here I am getting. So that is the delta I am able to achieve. So from very naked eyes, it's so clear. If my north is winner, I'm just considering my north and south game. So let's focus on that only first. So I am just considering, so whichever my maximum till that point, I will store my north south max till north and south. Whoever the max, give me them, right? That we just saw between north and south. Give me that and give me the mean also. Mean of north south. Give me the mean also. So mean of my north and mean of my south. So now very greedily that we just saw, I should convert some mean. I should convert some mean to max. I should convert some mean to the max category, so that my max can be higher and mean should be lower. My max can be higher, my mean should be lower. How a difference, like here x1 minus x2 we are trying, right? X1 actually, like let's suppose north and x2 is basically south. Let's consider x1 is north and x2 is south, and we have to take this delta, whatever it is, that delta, like x1 minus x2, we are trying to maximize this factor, right? We are trying to maximize this x1 minus x2 factor. How we can do? I have to try to increase this and decrease this. X1 I have to try to increase and x2 I have to try to decrease, right? So out of them, the maximum one should be my x1 and my minimum one should be my x2. Now my target is increase the maximum or decrease the minimum. So, but how far? So let's suppose I have, on that example test case only, I have my minimum is 2, and k factor is 1. So how many we can use? I should only use at least one. But let's suppose that is the case. Let's suppose my k is 3, and my this one is 2. Then on that case also, what I can use? I should use this two only to convert to fully on north. Then my north count becomes 5 and my south count becomes 0. So the delta becomes 5 on that case. So in that case also, if I have k is higher than my minimum, then also I am going to use the minimum count. If my k is smaller, then also I have to use then k count. So whichever the minimum, that many elements I am allowed to toggle. So what is then my general formula? What is then my general formula? So if I'm going to define a can use, my can use should be minimum of my k and minimum of my, out of them, this mean of my north and south count, minimum of my north and south count. Yes. So now when I got this can use, so what I should do, my max count, max of north south plus equals to can use. So that many I have to reuse, that many I have to add it to my north south max, because I'm going to convert that many minimum to my maximum. So I'm going to add them, and my minimum of my north south I'm going to minus equals to that can use part. I'm going to minus equals to my can use part. Yes. And you guys, and you definitely understood, I don't play the games with my k. Because I need that k for every point calculations, because here I am calculating my answer for a point, right? For till now how much. So here I am considering what is the formula. So I need my k for here also. So I can play my game with k, the given k. So I definitely need a temp k. I definitely store this k to some temp k and play the game. So what I can do, I can define a temp k initially before starting this gameplay, and I can define the k hat here, and I can play the game here. Rather than k, it should be my temp k. And I have used my can use, and now that many I have used, that many either k or from this bucket. So that many elements we have converted, right? Because that is the minimum of my temp k or my minimum of north south, right? So that many elements we are going to toggle. So that many k's we are definitely going to consume. So I have to also do temp of k minus equals to can use, because that many we are using, that many k we are using. So by using that many k, we are decreasing this mean north south count to that much time, because I am going to convert them to max value, to the max value. So either my north is max or either my south is max. I don't want to consider who is max. I don't want to see at all. So whomever is max, I am going to just adding that many can use to my maximum ones and subtracting that many can use from my minimum ones, and I am also decreasing my temp k. So that many temp k I have used for my north south. Is as I now. So that is the game only. So what is the then contributions? So by using them, I have moved my maximum to let's suppose a very extent. So for this particular example case, my max is now, let's suppose, at 4, for definitely 4, right? And my minimum, when my north count is 3, south count was 2, and my k was given as 1. So I have converted this south count to be, I have utilized all the 10k, and I have changed this 1 south to 1 north, so it becomes 4 and south becomes 1. So my max is basically pointing to 4, and my minimum is pointing to 1. So it can go to as 4. Then there is a single downfall of -1, and the resultant becomes 3. So what is then contributions to my answer? So answer contributions is nothing but, for this north south I am going to consider, for this north south, the resultant answer contributions is nothing but north south of max or max of north south minus mean of north south. So that is the contributions for this north south part, right? So similarly, now as I already told, my north south is going to independent for my east to west. Now you have to play the exact same game. You have to play the exact same games to your east to west, and you have to store it to your east to west resultant something. So that is nothing but your max of east to west, same code, exact same code. You just have to write. We will discuss definitely on the code iterations, but I am just high levels completing the pseudocode iterations. I am high level complete, right? So now when you have your resultant maximum southeast, right? Sorry, east to west, maximum north south. When you have these details, what is your then this particular points maximize? So I am going to maximum. So for every points I need the maximum. For every points I need the maximum. So finally we are going to return result for. Finally I'm going to return the answer for sure. So what is the maximum answer we have encountered for every points the maximum we have to return those. So for this particular points, what is the contributions? What is the contributions? Is nothing but north south resultant that we have plus east to west resultant. So this we have to maximize with my answer, and finally my answer should have for every points what is the maximum resultant we are able to achieve. So that is stored in my answer, and finally we are returning it. Yes guys, so that is the mathematics, or that is the equations lying to this particular problems. The major thing is you have to process your x-axis independently to your y-axis. So just focus, like make any problems to as granular as possible, like make it very granular. So when you have the opportunity to make it granular, make it. So done your entire algorithms ready for x-axis, then y-axis is just a duplications, just a create the same value, just pass the variables differently, and it will work for exactly same. So focus on the granular part solution. So you have solved for x-axis. Now similar functions maybe you can write it for like make it non-duplications. So pass the variables for east and west, it will going to calculate. Now calculate your answer for that particular points by maximize whatever the answer we currently have at to that particular points, north south and east to west maximize. Yes guys, yes, that's exactly we have to do. Now we can quickly do the code iteration. So we definitely need 4 variables for sure, north south east west. Everyone's to be defined with start with 0, and my answer for sure that is also start with 0. So variable declarations is very self explanatory, right? Very self explanatory. Yes, now I am iterating for each in S. So whatever the strings they have given. So if it is north, increasing north count. If it is south, it is south count. East, increase east count. Else, increase west count. Done. Job done. Define your temp k with k, because we are not going to distort our k. We need a temp k. Now north south max of my north south. North south mean of my north south. Can use is nothing but mean of my temp k and north south ka mean. Minimum of my temp k and north south mean. Whomever is minimum, I can use that many toggling. So I have defined my toggling count. Now do the toggling. We are toggle my minimum to the maximum, so its count going to be decreased. How far? Can use time only. So for toggling, which power I have used? Temp k power I have used. So its count also going to be decreased. How far? Can use time. After toggling, it's become my minimum becomes my maximum. So north south max count should increase. How far? Can use time. See guys, see code is going to tell itself what actually it's going to do. What actually we have to write. We are going to just have to declare the values in the correct path. It is going to autocomplete. It is going to be autocomplete by itself. It is going to tell yourself what the next lines you have to write. Now you have done your north south job. Same code, just copy paste for your east to west. Same code, just copy paste for your east to west. So east to west max is nothing but max of east to west. East to west mean is nothing but east to west mean. Can use mean of temp k, east to west mean. East to west mean minus equals to can use, temp k minus equals to can use, east to west max plus equals to can use. I have done with my north south max. North south mean I have updated them to the correct value. So north south contributions is nothing but at this particular point is nothing but north south max minus north south mean. Agree? So that is the contributions to my x-axis. On my x-axis side contributions, north south max minus north south mean. What is the contributions to my y-axis? Is nothing but east to west max minus east to west mean. So I have taken them all and I am maximize them to my answer. Yes, that's exactly what I am doing. And finally I am returning my answer. Yes, this is the game guys I am only playing. Agree? Totally agree. So now we can quickly discuss the time complexity of this. So I guess you guys should predict on your own. So the time complexity, we are just iterating a single for loop. So the time complexity is bound to be a big of n for sure. Not more than that by any chance. And on space complexity, do you guys see we have defined any extra variables? No. Any like data structures altogether? No. All are variables. All are like single initializations variables only. All are variables. So the space complexity is bound to be big of 1. And that is obviously most optimized time and space complexity you can achieve. You would definitely have to iterate at least from forward to backward. At least you have to iterate at least from forward to backward to compute your answer correctly. So that exactly we are doing with full optimizations, and it's bound to be the most optimized time and space complexity you can achieve for this particular solution. Yes, guys. So that's all about this particular question solutions, and I have tried my best to explain to you guys, and I know it's a quite good on different level of math based problems. The intuitions that we have done on whiteboardings on OneNote we have did. So on that actually the problem solutions is like. And if you guys are understand till this point, so guys, please do subscribe to our channel. Please share the videos to your friends circle who are also preparing for top product based company and brushing up their DSS skills. And please turn on the notification so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it, guys. That's it for today. Let's meet tomorrow with another beautiful question. Bye, guys. Bye.